connects to your RDS database. And then just like thinking about, well, how do each of these things fit together? So right now we have like a Flask backend container that we'll boot up. And then in the next lab, we'll have the Streamlit front end. And basically all we're doing is, so what we'll do is like someone makes a request on port 80 to the Streamlit front end. And then that will make a GET request to the Flask backend, right? Like make it probably do like slash positions. And then what will that do? That will make a request to your database, like select all, right? And so really this backend, if you think about the route, will be something like position.all, which really translates to, select all from positions, blah, blah, right? And then that gets sent back. So it's not, I think like this is everything, you all know this, but just drawing it out should like simplify in your mind all of the code that you're doing. So then it's like, well, where do the security groups come in for this? Well, we need security groups for port 80 on the EC2 instance to allow access for that. We need security group on SSH, right? Or we need a security group that allows access to the public on port 80, and we need to allow access on port 22 to be able to SSH into this EC2 instance. And then we also want to be able to access the database on port 5432, right? Because that's where Postgres is running. And so for that, we need a security group as well, right? So we need a security group for this. And then the other thing that you can see I have is on the security group, we have access to, have this tag of like EC2 security group. And what this is doing is basically saying, hey, I want to allow this machine to be able to access the database. All right. Basically anything that has this tag. So this instance is attached to this security group. And what we're basically saying is anybody who is attached to this security group can also get access on port 5432. All right. So, and you can see that, like, I don't know if I have my code up. Yeah, I can show you the code. Yeah, let's go to it. So you can start to see that in the code. Why would we require a security group for port 5000 as well? Would we require a security group for a group for port 5000? Well, if we were calling the Flask endpoint from outside of the EC2. Yeah, exactly. Right? So Conwell's pointing out, hey, like, what if you want to give access directly to your API, right? You can make a choice about that. Like, should people be able to access that API? And if the answer is yes, then you basically give access on port 5000, and then this backend that they can directly access the API. There are maybe it won't be the full. Probably the way most companies do this is they won't give access to all the endpoints, just some of them. So there might be like a separate kind of like user-facing API, and that might even be run on a totally different instance. Things like that. The other thing you can think of, once you do this, then you can start just thinking about like the architecture. Like maybe you just have an EC2 instance here, and then you have a separate EC2 instance here. What would be the benefit of that? Well, now we can get requests, straight to the API, and it doesn't have to tax my EC2 instance handling the front end, So you can like.
Yes, it's get called API. I've heard this term.
What is it? What was that term?
API gateway, the other interface you were referring to.
Yeah, I mean,
one which blocks.
I think that's probably true. Like normally, what they'll. I'm not. I'd have to like look at that more. But normally, there might be one. Let me talk about one issue. I think this will be a good way of getting at it. Normally, there's one more. There could be one more step before here, which is like kind of like your gateway to a load balancer. And the issue here, if you think about the issue right here, remember like every time we boot up Streamlit, like we can get a different IP address, right? Like the domain name that we access it at can be different. Like Amazon will just like assign us a different one. And And the same thing here, like the back end, if we put this on a different EC2, this domain name or the IP address can also be different. So you can, like, there's a different service, and I'm just having a block. I'm not able to think of the name, but so you can basically buy it, like a different service is like kind of like a stable IP address that then will route the request to here. And I think with like an API gateway, it's kind of the same idea. Be like a stable IP address, which will then send requests to your Flask, to your backend, to the EC2 instance hosting your backend. So we could, I was actually thinking about having curriculum on that, not for any time soon. This would be at like the very end of the course. But just so you know, like a typical way to do it is you'll have kind of like, you might have multiple EC2 instances. Like say you have, just in case, like, we become super popular and very wealthy. And so we want to make sure our site doesn't go down. So it's like, what do? You have replicas of this machine, of the EC2 instance, each of which holds a different Flask backend. And so how do you know which one to go to? Well, there's this piece, in between called your load balancer, right? And then you might have probably more like what you're talking, I forget the name, if it's like the gateway or something else. And so it's like you make a request directly to here, and that goes to the load balancer, and then the load balancer looks to assign the request to any one of these instances. So if it's like, hey, I want to make a request to like see all the job positions in Jeff's website, well, cool. There's 1,000 other people doing that too, hopefully. So which of these machines? The idea of having 3 of these machines is that we can split up the burden, right, between all 3 of them. So which one should it go to, right? The load balancer can alternate between all of them, and that way you can split this up, right? So that's kind of the idea. And you can do that directly with your website or with like an API. But I'd have to, I think that's probably kind of like what it's getting at, but I'm not sure when you say API gateway. But yeah, and in Terraform, by the way, it's very easy to like boot up 3 replicas. All you have to do, I think, is there's something. It's like you can just Google it or like ask ChatGPT. But in here, if you just do something like replicas equals 3, it's like that easy. I just forget the word. And it will boot up 3 exact same copies of your instance. So that's like a nice benefit of Terraform. But yeah, so what I was getting at is like sometimes it's hard to see the architecture just in through your code, but it's very nice if you have a diagram where you're like, okay, here's my security group, right? We have access on port 80, we have access on port 22, right? That lines up with kind of what we were showing here, right? Have the security group, access on port 80, on port 22. This allows for somebody to make a request, an outside request on port 80. It also allows for SSH access on port 22, right? And that kind of takes, and then we have this EC2 instance, and we associate it with this security group, and run this script at the front. And then we also have our RDS instance. An RDS instance, what's the security groups associated with that? Postgres instance, Postgres access on port 5432, and allow access to that web app security. And then you can look at your diagram. It's like, cool, public access, port 5432, and access to that security, the web app security group, which allows this Flask, this EC2 instance, request from this EC2 instance to be able to to go to here. The last point is, this came up in the last class, is like, what is the RDS instance? The RDS instance is still just, like, almost everything in AWS is really just an EC2 instance underneath. The RDS instance is just an EC2 instance. That's kind of like what is, the only difference is that it's already pre-installed with Postgres, and it like has settings that make it, easier, like that work with a database, right? Like when you kind of quit your database, your RDS instance, it asks, hey, do you want to take a snapshot and save the data, right? And then when you boot up a new instance, you can connect directly to that snapshot. So like does things like that works for you. It also like by default will try to give access on port 5432 and ask for create a database. You can specify the name, things like that. That just it like sets up your EC2. It sets up the machine hosting Postgres for you. Like it does. It helps with that. But really, what it is just another computer that has Postgres installed and running on it. Okay. But what's nice about it is like, say you don't want to have like a Flask API anymore, and you don't really need this service anymore. That doesn't mean you want to get rid of your database. Like your database is probably like the most valuable part of your application. It has all the data. You can always start up a new one of these guys, or rip it down and do something totally different. But like this is very important. So it's like if I want to get rid of this, I can just delete it. If I want to move to a different service, but like the database in itself is very valuable, so it's probably better than just like installing Postgres directly on the EC2 instance. Like you could do that the same way we have Postgres installed on our laptop, but this is better. It's more secure. It's also just a separate service, and you're kind of recognizing that that I wouldn't want to be able to like change this without having to worry about my database. All right. Cool. I think that's basically it. So what's next is, like I said, you're going to have to set up Streamlit to make requests to Flask backend. In order to do that, the lab will like walk you through it. There's a couple of things that have to happen. The first is you're going to have to create a network, like a Docker network, and that's going to allow Streamlit. It's going to like put Flask and Streamlit basically on the same network. So remember that whenever we use Docker, that we're not having ports on my host. We're not directly. It's not running ports on the host machine, right? It's running ports inside the Docker container, inside the Docker environment. In order to like have this guy say make a request to the Flask backend on at port 5000, and kind of like do that seamlessly, these should live in the same environment. And a way to do that is with what's called like a Docker network. So all you do, I think that just the command is like Docker, and the readings tell you this, Docker like create network, and then you name it. Name equals whatever, like your web application. So you'll just create the network, and then when you boot up the container, so it'll be like Docker run, you'll just specify the network name equals web application. Okay, and then you'll be the Flask backend. And then you do the same thing. So that will have, this running, the Flask backend running on the network, and then you'll do the same thing with the Streamlit front end. And now they're both running on the same network, meaning that basically they can talk to each other. And then all you need to do is, remember, this Streamlit is going to have a line in here that says something like, give me one sec. It says something like import requests.get to, and where does it make requests to? All right. As long as this backend, as long as you name the container, say you call it the container backend, you don't make requests to localhosts. Like localhost would be your Streamlit Docker container in this case. Like I said, how is it going to talk to this guy? But because they're on the same network, it actually can see this container, and you can just it's as easy as saying make a request to the name of the container that you want to make a request to. So backend /5000, and that will give you the response. And you just do response.json. So like I said, the lab will walk you through it, but basically you want to be able to, from this container, make a request to that container. And the way to do that is, step one, create a network in Docker, which is quite simple. Step two, you then say, hey, when I run this container, I'm going to put it on that network, network web application. And when I run this guy, I'm also going to put it on that same network. And now, because I've done that, this container can see that container, and you can communicate with it by just saying requests.get backend, make a request to basically this IP. It's essentially like an IP address slash 5000. So instead of saying localhost 5000 or the domain name 5000, the domain name is just the container name. All right? And that's kind of it. Yeah, Conwell.
Yeah, just a quick question regarding this network. Why we need to do this? My understanding was if we are running two Docker containers within the same computer, and we read about this Docker ecosystem, shouldn't that be like default network already, in which this container is running within this computer?
Yeah, they're separate. They're not necessarily Docker can you can have more than one network, within the Docker ecosystem. So to tell it that they're running on the same one, this is what you have to do. I don't know, just it won't work without doing that. Like I said, it's basically because you can have separate networks within the same Docker ecosystem. Yeah, but it's a pretty simple fix, right, to do this. And it's the same thing. Like when we get to Docker Compose, we'll see that it works very similarly. But it's kind of a nice thing. You can just access this container simply by typing the name of the container here. That's kind of the whole trick. All right. My code, if you want to look at my code, well, I guess I was going to say we could look at the solution, but actually the solution will be the start of the next lab too. But you can kind of see what I did. You install Docker, you start it up. We have these hey, wait, if it's not up and running, it basically, this is saying if I cannot call Docker PS, call a simple Docker command, let's restart it and then wait a couple seconds and then see again if we can call it. And then we just get to the next thing. Hey, pull down the image. If we cannot, if we list the image and we don't see it, then pull down the image and then just wait a couple seconds, right, before moving on. And try this again. If you see the image, we can skip this, then go to the next thing, do it again. And then we do the same thing. Hey, if you see a container already running, especially with this name, if my backend container is already running, let's stop it, remove it, same thing for our front end. And now, I guess here I'm doing it, creating the network, blah, blah. So that will be next for you. Cool. I think that's it. I do recommend, I think the main thing I wanted to talk about was just diagramming, because I do think you can see, at least to me, you can see how much simpler this feels than using your, than just looking through Terraform code. But it helps you understand, I think, everything that's going on. So I would, if you have extra time, which I'm sure you all do, I would recommend doing that. And the other last thing I was going to say is you can use this. I can put this in Slack. If you have Terraform code, I think I might have had to install that. I just Googled it. But you can call Terraform graph, and then it will spit out kind of a graph that can then be interpreted. So if I run this line, so you can kind of see what happens. I'll do open graph.png. And so what it does is it shows you the different resources that you created in Terraform and then shows you how they connect. It's okay. You know what I mean? I think if you see it, it's still kind of confusing. But they do, it's not its fault. It's just right? Some of the stuff we don't really need in there, right? This is the HashiCorp stuff, and this is our output, but it's at the very top, which doesn't make sense. So all of your resources are there. And then, it is, so this part's kind of nice, AWS Postgres instance, we have a security group, right? And then we have attached access to, in the web app, right, to those who also have that web app security group, get access to my Postgres instance. This talks about that template file that we run, which is part of the EC2 instructions, I guess, somewhere. Well, here's my backend server, which I think connects to this, which connects to the init. So it does all kind of work, but it doesn't help my brain so much, like just a little bit. I still think that doing something like this makes things a lot more clear. All right. But I can put that command in Slack, and you can just Google, like, how do I graph, Terraform, a Terraform script, and we'll show you. All right, I'll put you all in breakout rooms, and basically